All right, good morning, everybody. All right, so welcome to our final presentation for our 2016 launch event. So today we're going to be focusing primarily on the different simulation packages. So we'll talk today about our SOLIDWORKS Simulation, SOLIDWORKS Plastics, and SOLIDWORKS Flow Simulation. So those will be the topics of discussion today. So we have broken it down today to 3 sections. So quick agenda, so you guys all have an idea for what's coming. Now, for today, I do have Jared Spaniel out of our Northern California office helping me out with the presentation. I also have Quentin Rock and Michael Nolte. All right, so let's get started. Like I said, our first presentation today, we're going to start talking about SOLIDWORKS Simulation specifically. So we're going to talk about some of the changes that have been introduced this year just to SOLIDWORKS Simulation. Now, I have a lot of great enhancements I want to show you this year. I'm going to try and take it a little bit slower today just to kind of highlight what these are and show you different use cases. And there's been a bunch of them, so I'm going to start with this first one here. So this year, SOLIDWORKS actually introduced a new functionality for us to turn off a load, or essentially tell a load when to stop being compressed or turned on or off. So you'll see I have a couple of different nonlinear studies here on the bottom for us. I'm going to go ahead and access this first nonlinear study, and we're going to take a look at one of these fixtures here. So in this case, we have this fixture, this reference geometry of negative 1.5 millimeters. Now, when we apply these fixtures in the nonlinear, we can also apply these things called curves, right? So on the bottom, we can come in and we can say how it's applying the load at different time steps throughout the simulation. New to SOLIDWORKS 2016, we actually now have the ability to come in here and tell the software to turn these things off. So no longer just saying simply put it at 0, but to simply just ignore this thing now. So it's no longer not allowing it to move at all. It's just simply saying that that fixture doesn't exist at that point anymore. So in here we can see at 0, the fixture essentially is not present. At the 0.61 mark, we're essentially saying that that face is not allowed to move at all. It's stuck at the 0 range. At the 0.7, it's at its full. It's at the full amplitude. And then once we get back to the 0.77 seconds, it's turned off again. So the fixture essentially disappears or is not present any longer. So we now have the functionality of going here and no longer have to try and figure out where that placement's going to be, inducing higher or lower stress values because we're holding something in place where it's not actually supposed to be. But we can now simply say, I don't want that thing to exist anymore after that point or before that point. So a good example of this, let's go ahead and just play the result here so we can see what this simulation looks like. So this is a clip, right? Like a backpack clip. As we push this thing together, we're going to see this thing flex in and then flex back out. And then as we pull it apart, we want to push this edge in, pull it back out. So something that may have been difficult to do in the past, right, as we had to go in manually calculate how this thing was going to push apart, or we had to create 2 different configurations of it. Now we can do it all in a single simulation. So we'll go ahead and play the result here for you. I'll slow it down just a bit. So as it actually gets pushed in, we can see as it creates the stress concentration for us, performs that snapback functionality, and then as the next fixture is actually turned on, causes it to push inwards, and then the fixture is released and allowing it to slide out. So this is new functionality that's been added this year for us, just this capability now of turning that fixture off and on at different time steps. We'll play that one last time there, and let's go on to the next one. All right, so for the next content that I have here for you, SOLIDWORKS has also introduced this year a new way of evaluating the mesh quality for us. So I have another model here set up for us. I'm going to go ahead and open up this simulation case. And we're going to evaluate the mesh here. So I'll go ahead and show the mesh to start. And this is where a lot of us, sometimes there's a lot of confusion, right? As we try and understand the mesh quality, what's happening with the mesh internal to the model, sometimes we just have to make assumptions. New in SOLIDWORKS 2016, we now have a way of evaluating the mesh with the new mesh sectioning. So if I'm curious about this region as it is, and want to see what the mesh is looking like 3-dimensionally as it moves into the depth of the object, I now have a new option for evaluating that mesh. So under this mesh quality plot, if I right-click on it, we'll go ahead and show the mesh quality plot, and I can right-click on it, and there'll be an option now for mesh sectioning. Now this mesh sectioning allows me to see the internals of that mesh. So I can actually zoom in And I can evaluate how the tetrahedrals are actually placed and what they look like as we go through the depth of the model. So we can start to evaluate the stresses and everything that's moving across it. We can do this in more than just the mesh settings preparation. So as we're looking at it now, we're just looking at it from the mesh side of it, right? So some of us might be curious to see this thing in an actual simulation result. So let's take a look at this stress plot. Now as we look at the stress plot, we can see as it generates all the colors for us, lets us know where the stress concentrations are. And we might want to dig in more and try and figure out what this thing looks like in a section view, right? So previous years, what we would do, come in here, do section clipping, find the location that we wanted the model to be at, and it would break down so we could just see that flat face. So first option this year, we do have that option there for that show mesh on the section, which is just a 2D representation of that mesh for us. So we can see how it's outlining it on our cross section for us. Additionally, there's another option when evaluating this for the mesh sectioning. So the same option that we saw with the mesh quality plot, we have that mesh sectioning. Turn it on and see the result across the mesh elements. And if we want to highlight the edges, I can also check this box where it'll show the edge and give us nice black lines to highlight each of the different nodes there for us, each of the different elements. Now we can see the stress concentration as it moves across the element. So far 2 tools that have helped us to evaluate the simulations in a new way. Let me show you a couple different ones that have been introduced this year as well. Let's start with this this crane here. Now, just coming into this, you'll first notice that there's a number of different surface bodies. So there's a reason for that. We'll get into it here in just a second. First thing I want to do, though, is I'm simply going to run this analysis. SOLIDWORKS has done a lot of work this year to try and help us understand the errors that we're encountering as we go through these different simulations. And this year with errors, you'll actually see that there's been a change to these things. So they've reduced a lot of the convolutedness to some of these error messages. And we can actually see now as it pops up, it's giving us now feedback about what's happening with the model, giving us tools that we can use, and also giving us a link now that we can click on that'll take us to a knowledge base. In some cases, for specific errors, it'll actually take us to a specific article about that error message, so we can learn more about what's happening and try and fix this problem. So in this case, we can see that the model's unstable. We want to check and make sure that there's enough fixtures that the body is stable. So in this case, what we're seeing is that some of our bodies might not actually be fixed into their positions. And the reason for that is this thing is a welded structure, right? So the thing was actually modeled with some gap between the surfaces to accommodate the tolerancing and the welding that's going to occur as well. Now, in SOLIDWORKS 2014-15, all those other versions, right, we'd all know that we have to go in there and create these different contact sets to figure this stuff out. But we had to know beforehand how the model was built and that those spacings were present, or we had to go through a different number of steps to figure out which bodies weren't quite present or weren't quite touching. New in SOLIDWORKS 2016, you'll see, there's an option for us to actually come in here. I'm going to go ahead and look at this contact visualization plot. And inside the contact visualization plot, you'll see there's a new option for under constrained bodies. So in the top bar here, I can check on this under constrained bodies, and it'll actually run a quick calculate and find all of the different bodies in this simulation which are not contacting, which are not touching something else or not fully defined in their position. So it's going to run this quick analysis for us. And what it's looking at is each of those different bodies that we had defined. They all have a material property to it, and they're just not touching something, right? So there's nothing to hold it into position. It's evaluating everything in this model to see. This worked this morning. I think, my apologies. I'll go ahead and continue with this one. So it does work. There's actually a article in the GoToWebinar. If you guys go in and download that, it will walk you through the process of setting that up. Now, what the under constrained bodies was actually showing us is all those different pieces that, with that weld gap, the directions they were moving in, all the degrees of freedom that they were not that they were not defined in. So a new option for SOLIDWORKS 2016 for these shell faces, all these different shell elements that we've created, or all these different shell components that we've created, is a new option in the global contact set for the non-touching faces for shell edge to solid shell face pairs. So when we have a shell edge touching a solid or a shell face, a solid face without an edge on it, that it can create that component contact. So I'll go ahead and right-click on this global bonded contact, click that edit definition, and under the non-touching faces option, you'll now see there's a checkbox for include shell edge with solid shell face pairs. So again, the shell edge, so as we look at this, we have that blue highlight, touching this solid surface, a solid face. Hit that green check mark, and then simply run the analysis. So this time with that checkbox turned on, we should not receive any error messages about unconfined or undefined bodies now. So just zoom out, we can see that now with that, it ran, everything's good with that checkbox turned on. So the last couple of options that we saw for 2016 and introduced, I'll show on this last model here. I have 2 more for you guys, and then we'll transition to a couple poll questions. Actually 3 more, and then we'll transition to a couple poll questions. And start with our plastic section. So I have our first model here. Now I set this model up for a couple different reasons. The first one I want to show you is new in SOLIDWORKS 2016. You can now actually create a bolt connection on the same part. So where we have the top edge and the bottom edge on the same component, this U shape that we have here, bolt connectors will now work on this single component. So we have 2 separate bodies in here. The first inside body, and then the outside C-shaped body. So first, update this here. The bolt connector now works appropriately with this single body. Secondly, you'll see that there's a new option inside the meshing. So as we create mesh, we've traditionally had the 2 different options, the standard and the curvature-based mesh. New this year, there's a new blended curvature-based mesh. So that if you've gone through and worked on the curvature-based or the standard mesh and are not able to get these working correctly, you do have this last option now for a blended curvature to try and kind of tackle that meshing problem. And then the last change, for those of us that have different results that you might be trying to pull out, right? So sometimes we see the stress plot, we might want to get more out of this, or we might want to get more custom information out of this. So we'll have to take these values out of here and actually plug them into some equation. New in SOLIDWORKS 2016, we can actually create result equations. So selecting this new option, result equations, will bring up a dialog box for us, where we can evaluate based on the node values or the element values and start building in an equation. So in this case, I feel von Mises stress. I can start creating a different equation based off this, so times 5, 6, whatever, and start to do different forms of functions, right? So as you pull them out of the textbook and just simply recreate them into this this field here, you can get those results to publish for us. So that concludes what's new for the simulation side of this. Just real quickly to go over some of the new functionality, we have the section meshing, the toggling of the prescribed loads. So when we add that load, we can turn it off essentially. We have improved error messages, that new under constrained bodies check, single body bolt, and equation-driven results, a new way of evaluating the results with that section meshing again, and a new meshing option. So with that, we'll go ahead and transition over to Jared for our plastics presentation.
All right, good morning everyone. Thank you, Brad. So what I want to talk to you guys about today was some of the new features added in SOLIDWORKS 2016 for the SOLIDWORKS Plastics add-in. And what I want to start out with was just quickly showing the SOLIDWORKS Plastics matrix for those of you who don't know. You know, plastics is a separately purchased product similar to simulation and flow. And we have the 3 packages, Standard, Pro, and Premium, that can be used with SOLIDWORKS Standard, Pro, and Premium. And these are kind of the features for each individual package. So, you know, with Standard, you get filling, short shots, air traps, weld lines, etc. And then with the upgrade to Pro, you get a couple more features like multi-cavity, cooling time, gas assist molding, co-injection. And then, of course, if you're going to look at some more advanced things in plastics like warp and cooling lines, you would need to have the Plastics Premium. So I just kind of want to let you guys know about that breakdown of which options come with which packages. So the first new feature that I want to look at was the addition of now the runner domain to the SOLIDWORKS Plastics, and I'm just going to show you in SOLIDWORKS what that looks like. So this is, of course, SOLIDWORKS Plastics. I just have a simple part here with a runner. And just like Sim or Flow, you have the SOLIDWORKS Plastics tab up here. From your add-ins menu, you turn on Plastics, you get to the SOLIDWORKS Plastics tab, and you get your command manager to come up with quite a few extra plastics-related features and commands. So over here in the mesh, what they've added was the runner. So if you go to the mesh in the property manager over here, you open the property manager for solid mesh and you go to manual. And what you can do is now set up a feature for this runner. So here you can see I have option for runner, and I can assign a runner domain to this under domain type, whereas before we had cavity, insert, cooling channel, and mold. Now we have runner. So I can assign a number 2, I can say this is a runner, and then I can have my cavity and my runner, in this case, on 2 separate domains. So that's kind of what they added for the runner feature this year. So the next thing was the next improvement was to the solver performance. So now we have a couple different options for solver performance improvement, and what the graph here is showing is your solver speed with multiple cores. So as you increase your cores that you're using, or the hardware of your cores on your computer, you can see my solver time will decrease, which you would expect. What we've also added is now the flow and warp analysis are improved, and we have a new solver called the 6SAM, which stands for Compressive Interface Capturing Scheme for Arbitrary Meshes. That's quite a mouthful there. So this is a method for flow front tracking, and it's now the default flow solver for the plastics injection molding analysis. And we also now have a quadratic mesh option for the warp solver, and an option to control the solver CPU number, so you can change your numbers to whatever you need based on your computer. So a couple things to look at in here. The way you get to a couple of these, the first one was the under process parameters and fill settings. When you go to open settings, you have a drop down here for solver settings and then options. So if you open up your options, this is how you would get to your solver type. So it's under volume of fluid algorithm, and there's 3 solvers. There was direct, indirect, and now there's this new 6SAM solver that is the default here. So we have these 3 solvers, and the 6SAM is the default. So that's how you would get to changing that options for solvers and that for fill settings. And then the second one was under warp settings. So if you go to warp settings, open settings, and then under solver settings, similar to fill, you have an options tab here. You click options and you get this checkbox. So this is to check off this high quality mesh or quadratic solver, and this is for warp. So if you're doing some warp analysis, you probably want to have this checked off to get some more accurate warp results. So that's how you get to the mesh solver for the warp process parameter. And then the third thing was the CPU solver number. So under settings and help, you go to settings, and then down here you see you have the solver CPU, and you have this box with the up and down arrows, so you can change the number of solver CPUs that you want to use for your simulation in plastics now. All right. So a couple other features that they added this year were they added the some enhancements to the report template for improved readability. So now it includes some more sections such as introduction, model info, material properties, process parameters, flow pack, cool, and warp results, a conclusion, and you can of course publish these reports just like you can in simulation to a Microsoft Word format and create a custom template as well. And then they also updated the user interface a little bit more to conform kind of to the SOLIDWORKS software interface for improved usability. So the command manager is updated to contain, most commonly used commands in plastics and stuff of that nature. So the report down here on the feature tree, you get your under results, you have a summary report, then open report. So if you can do open report, right click, you can open it in Word or HTML and actually have the Word open. So we'll kind of take a look at that report and see what it looks like. So this is the plastics report. So this is, an awesome feature for any of you guys who need to present your results very quickly to management. Of course, you're going to have to type, do a little bit of typing in here and fill in the introduction and stuff, but you get this nice pre-generated report with, all your part information, weight, size, your table of contents, of course, your material properties, all your process parameters for molding. You get your curve data, your polymer thermal expansion coefficient graph, and you can, of course, customize this however you want it to look. And then for the plots, they added this label min and max, so now you have your min and max within your plot, which is a really great feature, so you can quickly see what your max injection pressure is, your max injection fill time, to see if that is going to be comparable to using whatever injection molding machine that you want to use with it. And you get your temperature end of fill, pressure. So you get all these nice plots with all your min and maxes pre-generated for you, so you don't have to go in there and copy and paste and drop all these in. So in summary, what we kind of talked about was the addition of the category for the runner domain being added to the existing domains. And then we talked about the improved report template in Word and all the enhancements for improved readability. We touched on the user interface, so now the UI conforms more to the SOLIDWORKS software interface. The command manager is updated with commonly used plastics commands. And then, of course, the new 6am solver and the ability to specify the number of CPUs you want to use, and then the ability to add the quadratic element warp settings for more hi-fi results and more accurate warp results. So with that, I'm going to go ahead and turn it back over to Brad.
So let's jump in and talk a little bit about the enhancements to flow simulation this year. So there's been 3 major enhancements that I'm going to review for you today. Hopefully you guys can all stick around with me here for a couple more minutes. So the first one that I want to discuss, actually I'm going to stay with the PowerPoint to discuss this one for a little bit before we jump into the simulation, is a new option for enhancing the mesh, or defining the mesh and the surrounding geometry. So in previous years, if we wanted to create kind of a refined mesh as we move away from the geometry, sometimes we actually had to go in and model outside surfaces or outside solid bodies and apply a denser mesh onto those bodies themselves. So new in SOLIDWORKS 2016 is now an ability to add this equidistant mesh. So we can come in here and simply define kind of an offset mesh from our surface bodies to start seeing, as we get closer and closer, that the mesh density will increase. The results will essentially become more accurate. So this is a quick preview of kind of what the goal is for this. Now, there's a couple different options for setting this thing up. In the options here, we can go and we can set the offsets, how many offsets we're looking for, and the number of shells, the number of layers that we're going to create. So in this case, we're looking at 4 different layers, 1, 2, 3, and then 4. We can define each of the different distances here. So for the first layer, second layer, third layer. And what we start to get is we start to get a mesh that looks something like this. So we have this layer that's essentially surrounding our geometry, and inside that layer we're looking at refining any of the different elements. So in this case we have the one equidistant shell with 1 layer defined. In this image we have the one equidistant shell with 2 layers defined. So we have this refinement going on here. So I'll just jump through a quick couple of different one of these so we can see kind of how it's doing the refinement for us as we add additional layers. In this case we have 3 different layers, 4 layers. We can start to see the level of buildup and the quality of the mesh as we get farther and farther away from the actual geometry of the model. And then we can transition into the 2 equidistant shells. So we have 2 different shell options here with the number of 1 layers defined. 2 layers defined. 3 layers defined. And 4 layers defined. So again, we can see the level of detail that's coming in at the mesh as it gets closer and closer to the geometry. Now, previous years, again, this was a little bit convoluted, right? Because we'd have to actually generate geometry surrounding this and apply a very dense mesh to that geometry and then remove that geometry from the simulation itself to get something like this. So we get this tiered approach moving away from the geometry here. So let's jump into SOLIDWORKS and look at how this thing is actually set up. Now you'll notice inside of SOLIDWORKS 2016 that there's been a couple changes to the actual feature tree here for us. also into the command manager. So they've cleaned this up quite a bit for us. They put only really what we need there. There's not as many buttons up there that we're not going to utilize anymore. All those tools are still present in the actual tools dialog box going through the flow simulation, but for the most part we've tried to clean this up for you guys and make it easier to use. Now, creating this new this layered approach to the meshing is, you'll actually notice that there's a new mesh category inside the feature manager on the left hand side here. And under the local mesh, we can actually define these different layers, so equidistant refinement. And that's as we start to jump away. So I have 3 shells that have been defined in here with their different offsets and 3 layers. So we'll go ahead and take a quick look at the actual result here. I'm going to show the result in just a mesh plot. So as we meshed it, now we can see the level of refinement that's occurring as part of the simulation. So with this local mesh defined with those 3 different layers, we can see as we start to step away what the refinement quality actually looks like. So in the top level we have 0 refinement, the blue. We have a level of 1 refinement in this teal color, 2 in the yellow, and then 3. So I have a number of different simulations up here on the left. You can see through the configurations, which essentially goes through the same thing as we saw on the slides, right? So as I click on this level 3 shell, or the 3 shells, 2 levels, we can do the same thing. We'll load the result, and then we'll quickly show the plot. So we have our level 1 refinement, our 0 refinement, level 1, level 2, and then we have no 3rd refinement in here. Now, this is useful, right, because it helps us to improve the accuracy of our simulations. So let's take a quick look at some of the different plots that we're generating because of this. So take a quick look at this first cut plot here. In the cut plot, we are looking at the result of the pressure. We can start to see the pressure gradients as they're being generated, but we can also see we have the option checked to show the mesh overlay here. It's also useful because we're getting finer detail, right? So as we go through and do the different results evaluation, like this flow trajectories, we're starting to get more accurate results to what we kind of expect out of this, and no real penetration on the model as we're going through. So we're actually conforming to the edges without having to do all the extraneous information as far as generating additional geometry surrounding it and then refining that geometry. So that's the first option. Now, for the second big change that we're seeing in SOLIDWORKS 2016, let me go ahead and close this one, is we're starting to get support for symmetrical models. Now, a lot of us in simulation do this just naturally, right? So we create a simulation like this. We look at this model and we see that this thing is essentially symmetric, so we'll create the simulation with the domain of the body just slicing this thing in half. Now, new to SOLIDWORKS 2016, you'll see that there's options on the right-hand side here for us to evaluate the symmetry. So we can turn that symmetry on for us. But when we evaluate the results, there's new checkboxes in the results to actually view the results as symmetric results. So I'll go ahead and section this thing, so we're cutting it in half. We've only simulated half the model, so the half that we're looking at, and the half towards us is not simulated, right? So it reduces the amount of computation time required. And when we look at the results, typically the results have only been on the half simulated. Now, in a plot like this, it doesn't bother us, right, because we're down the cross-sectional half area. But when evaluating a plot cross-section-wise, we would only see before the 1/2 the plot. Now, in 2016, with the symmetrical option on, you'll get a checkbox when you create these options to mirror the results. So without the mirrored results option on, we'd only see the half that was actually simulated there for us. Turning it on would give us the full thing, like that. This also works with the surface plots. So if we generate any surface plots, you'll notice that there's that checkbox in the surface plots as well for the mirror results. So we can see the result throughout the entire body there. All right, and the last change to SOLIDWORKS 2016 was to the transient analysis. So as we run time step-based studies, sometimes these things took incredible amounts of time to complete, right? So new to 2016, there's been refinement to the way transient analysis have been completed. So you'll see that I actually have these things named as standard, nested, and nested with 12 iterations versus 25 iterations. So a new option inside of SOLIDWORKS 2016 is you can do an iteration control, maximum number of iterations that are allowed to be induced in the transient analysis. So how we get to that, evaluate the model. Under the calculation control options, we can go to the solving option, and you'll see that there's a checkbox here for nested iterations. And in here we can set the maximum number of nested iterations. With this maximum number of iterations, we can also do the normalized mass, all this stuff, but we can look at the actual solve time. So I just have a quick example here between the 25 iterations and the 12 iterations. We'll go ahead and load the quick results between them and evaluate the difference in the solve time. So on this 25 iteration one, we just go briefly look at the summary of the study. We can see how long it took to solve on my laptop here. It took 3,309 seconds. So again, 3,309 seconds for the 25 iterations. In the 12 iterations, I want to run it again, I want to load the result. It took 1,679 seconds. So changing the number of iterations, controlling the iterations will actually help us reduce the time. So depending on what you're looking for or the study type you're trying to run, it can significantly impact the run time of the simulation. So those are my 3 big ones for SOLIDWORKS Flow Simulation. As far as 2016 content, that's all I have to show you guys today. So again, thank you guys all for joining us. Otherwise, thank you all for attending. We look forward to seeing you guys next time.